This is Katie Bowman's AP problem number 1. So let's start with the question. Water is added to 4.267 grams of UF6. The only products are 3.730 grams of a solid containing only uranium, oxygen, and fluorine, and 0.970 gram of a gas. The gas is 75% fluorine and the remainder is hydrogen. So let's start with part A. From these data, determine the empirical formula of the gas. So, here's part A. We're going to start with finding fluorine. So I'll assume 100 grams of the 95% of fluorine, which will give us 0.95, not sure percent so you know. And we're going to multiply it by the grams that they gave us for the whole entire gas compound, which is 0.970 grams. When we multiply them together, we get 0.921 grams of fluorine, and we're going to convert this into moles. So we'll take the mass of fluorine, which is 19 grams, and put that on the bottom, and we're converting to moles, so that goes on the top. When we put all of this into our calculator, we end up with 0.0485 moles of fluorine. So now when we move on to hydrogen, we start with the grams that they give us for gas, which is 0.970, and we subtract out the grams that we found out for fluorine, so that we can just get them out of there. When we subtract, we get 0.0485 grams of hydrogen, but we want to convert it to moles. So we're going to put moles on top, grams of hydrogen on the bottom. When we divide these two numbers, we get 0.0481 grams of hydrogen. So to get the subscripts for our compound, we're going to divide both the numbers by the smallest number that we were given, which ends up being hydrogen. So we're going to go right here. We're going to divide this by 0.0481 moles, and it's of hydrogen, and we're going to do the same thing here. It's going to be 0.0481 grams of hydrogen, and this is going to equal 1, and this is also going to equal 1. So our final compound is going to be FH. So that's our final compound for the gas. Now let's move on to part B. So this is part B, and we're going to read the question for it, what we're going to be doing. So part B is what fraction of the fluorine of the original compound is in the solid, and what fraction of the gas after the reaction. So we're going to take So first we're going to start out by finding the moles of fluorine in the original compound. So we'll start out with what they give us in the initial question, which is the amount of grams in the UF6 compound, which is 4.267. We're going to convert it into moles, so we're going to take the molar mass of UF6 and put it on the bottom. The molar mass is 352. We put moles on top. We want to cancel out units over here, so we put 1 mole of UF6 down here, and on top we're going to put 6 moles of fluorine. And we know it's 6 moles because if we disassociated UF6, we would get 6 moles of fluorine. So when we put all of this into our calculator, we end up with 0.07273 moles of fluorine in the original compound, or OC. So now we're going to find fluorine in the gas. So we're going to take the moles, which we found in part A of fluorine in the gas, which is 0.0485. We're going to divide it by what we just found over here, and then we're going to multiply it by 100 to get a percent. What we end up with is 66.68% of fluorine in the gas. So now we're going to find fluorine in the solid. This is really easy. All you do is you take 100% and you subtract out 66.68, which is just the fluorine that goes into the gas, and you get 33.32% of fluorine in the solid. So that's it. Those are your final answers. Now we're going to go and move on to part C. So part C is, what is the formula of the solid product? So we know our solid product has uranium, oxygen, and fluorine. So we'll start with fluorine because we have the most information on that. So we'll start out with the moles of fluorine in the original compound, which we just found in part B, which is 0.07273 moles of fluorine in the original compound. And we're going to subtract out the moles of fluorine that go into the gas, which is 0.0485. And that's going to give us 0.02423 moles of fluorine. Now we're going to move on to uranium, and we are going to start with the grams that they give us in the original question of the UF6 compound, which is 4.267 grams. We are going to take the molar mass of UF6, which is 352, put it on the bottom. We're going to convert UF6 into moles, so we'll put 1 mole of UF6 on the top. We need to cancel out our units over here, and we are going to put 1 mole of uranium on top, because if we disassociated UF6, we would end up with 1 mole of uranium. And our answer, when we put all that in our calculator, is 0.0121, and it would be moles of uranium. So now we're going to move on and find oxygen. So oxygen, we're going to take all of the units or the grams that they gave us in the original question, and we're going to make an equation out of it. So we're going to take 3.73 grams of the solid, we're going to add it to 0.90 grams of the gas, and we're going to put an equal sign right here, and on the other side of the equation we have 4.267 grams of UF6 plus H2O, which is our X, it's our unknown right now. When we add these two numbers together and then subtract over 4.267 to the other side so that we get H2O by itself, we get 0.433 grams of H2O. So we're going to do what we did right up here with uranium, and we're going to do the same thing with oxygen. So we take this number and we need to convert it to moles, so we put the molar mass of H2O, which is 18.02, on the bottom. We convert to moles, we put 1 mole of H2O on the top. We need to cross out units, so we put 1 mole of H2O, and then if we disassociated H2O, we would get 1 mole of oxygen, so that goes right up here. When we put all of this into our calculator, we get 0.0240 moles of oxygen. And what we need to do now is we need to take the smallest number that we've been given out of these three, and we're going to divide all of the answers by that. In this case, it's uranium, so it's 0.01212. So we're going to go right here, we're going to go 0.01212 moles of uranium. We're going to do the same thing right here, 0.01212, and right down here for oxygen, same exact thing, 0.01212. Alright, so when we do this in our calculator, we get 2. For this one, we get 1, and for this one, we get 2. So our final equation for this is UF2 O2. Alright, so that's our final equation for the solid. So now we gotta move on to part D, which is right here. So let's read it out. Alright, so part D is write a balanced equation for the reaction between UF6 and H2O. Assume that the empirical formula of the gas is the true formula. So our final equation for this is H2O, UF6, UF2O2 plus HF. So what we need to do now is balance out the equation so that there's the same amount of molecules on each side. So first we're going to record how many of each element is on the reactant side. So we have 2 hydrogens, we have 1 oxygen, we have 1 uranium, and 6 fluorines. And now we're going to look at how many of each element we have on the product side. And we have 1 hydrogen, 2 oxygens, 1 uranium, and 3 fluorines. So we are going to start by we're going to balance out the fluorines. So we have 2 fluorines right here and 1 right here. We need 6 in total. So if we have 2 here, we need 4 more. So what we're going to do is we're going to add a 4 right here, it gives us 4 fluorines, which we add to the 2 over here. We come down here and we write 6. But since we put it here, it also gives us 4 hydrogens. So we have to come over here to the product side by the hydrogens, cross out, and put a 4. Now we're going to balance out the hydrogens. So we'll go over to the reactant side because that's what's lacking right now. And we look and we have 2 hydrogens and we need 2 more. So we're going to put a 2 right here. So when you multiply 2 times 2, that gives us 4 hydrogens. And since there's an oxygen right here, it also gives us 2 more oxygens on the reactant side. So we cross out this one and we put 2. And that did exactly what we needed to do. And now we have a fully balanced equation. It goes 2, 1, and then a 1 would go right here. And then we have a 4 right here. So 2, 1, 1, 4. And that's it. Thanks for watching.